Hello everyone. Let's have a look at a tutorial on airline scheduling. The content for this tutorial has been generated by an NPN intern by the name Yash Kapshikar, who is a student of third year BTech in Mechanical Engineering at DJ Sanghvi College of Engineering in Mumbai. He has been a topper of two of my NPTEL courses, the Lighter Than Air Systems course, which ran in the first half of 2024, and also in the course on Introduction to Aircraft Design that ran in the second half of 2024. So now he is helping me in generating the content for this course on air transportation. We will start by recalling some concepts regarding scheduling, but it is important to note that you will not be able to appreciate what we are doing unless you watch the lecture on airline scheduling before doing this tutorial. So if you have not watched that lecture, it's a good idea to stop watching this video, going to the playlist of the course, locating the detailed presentation on airline scheduling, watching that and then coming here, so that you can really appreciate the concepts much better. Just a recall that there are four major tasks in airline scheduling. The first of these is to design the schedule in which a competitive timetable is made to meet the potential demand and also to delay the recovery. After that, we do fleet assignment, in which we assign a particular aircraft type to fly on each sector to maximize the revenue on that sector. Notice that the demand for travel could be quite different on different sectors. So if an airline has multiple types of aircraft, then they can decide which is the most appropriate aircraft to be assigned to a particular route. So that is called as fleet assignment. In case an airline operates only one kind of aircraft, then you don't have this particular issue. You can straight away go to the next step, which is the aircraft routing. In aircraft routing, among the fleet available to us, we assign a specific aircraft to a specific flight. And today we will take up a small exercise related to aircraft routing and to highlight the complexity that an airline faces while doing this task. And finally, it's not enough to just assign a specific aircraft among the ones available on specific routes. You also have to match it with the crew that will be required to operate the aircraft. By crew scheduling, we mean both the cockpit crew and the cabin crew. That means the pilots in the cockpit and also the stewards, air hostesses who operate inside the passenger cabin. So we have to assign duties to specific crew members so that we can maximize our resource efficiency. So as I mentioned, among these four tasks, today we will do a small exercise related to aircraft routing. So pictorially speaking, the first activity is the design of the schedule, in which you plan what frequency you will operate and what timetable you will follow. That directly leads to the next task, which is the fleet assignment, in which we choose which aircraft among the ones available or which aircraft types among the ones available will be assigned. After that, we do the routing. While doing the routing, we need to take care of several constraints and limitations, such as the constraints due to maintenance and the constraints due to the capacity of performing the maintenance tasks. Then once we have completed aircraft routing, we can go for crew scheduling, where you have a crew pairing. That means in the normal aircraft, when you have flights of up to 8-hour duration, in today's scenario as per the regulations, we need to have minimum 2 pilots in the cabin. So which 2 pilots will be paired together, and then also how to roster them so that there are certain requirements which are met. These are highlighted in the lecture on airline scheduling, which I would urge you to have a look. Now, what is the requirement or the need for airline scheduling? The requirement comes from the overarching aim of an airline to maximize revenue, which will hopefully also give you the maximum profit. And for this, we need to create a timetable which meets the various requirements, some of which are very complex. For example, the arrival and departure times for the aircraft, and also at which location they are operating from and which location they are arriving. Then, as I mentioned, fleet assignment, and then there are many other constraints, some of which I have spoken about and some of them I will try to demonstrate in the problem. So, the whole idea is to reduce the costs related to the key items that lead to a large increase in the cost, such as the fuel, the maintenance and the airport gating. So, now let us look at what are the challenges which are faced by the people who do the scheduling of an airline. So, you have to ensure that all the players in the air transportation system, the passengers, the cargo, the aircraft and the crew, they are all flowing concurrently. Any of these could become a bottleneck, and the absence of any of these could lead to wasteful expenditure in waiting for the particular element to arrive. Okay. There should also be enough time for the influx and efflux of passengers, and parallelly for servicing of the aircraft between 2 flights, which is the basically line maintenance checks. Then if you look at the aircraft maintenance, we have to be very careful that the check A or B, that has to happen only at specific locations where the maintenance facilities are available, generally called as the maintenance base of the airline. That is the place where all aircraft have to eventually end at the end of the operations. They should turn up at that point, so that maintenance can be done generally during the overnight period. We also have to manage the ground resources optimally. And what are these? The ticketing desks, the ticketing staff, the check-in, the baggage drop-off gates, all of them have to be managed. Sometimes they can create constraints on the scheduling. So, keeping this in mind, let us have a look at a toy problem in aircraft routing, in which we are only going to look at 4 aircraft of the same type operating by an airline that connects only 4 cities. So, this exercise is going to be limited to only the connectivity between 4 cities. Now, remember, it is a toy problem. So, what do you mean by a toy problem? A toy problem basically means a problem that is only utilized to demonstrate the concept, and it is not exactly a real life problem, it is a very small problem. But when you solve toy problems, you get an appreciation of what are the various issues involved. So, this problem is related to a theoretical domestic airline operating within the country. This airline is expected to connect 4 metro cities, viz. Bombay, located here, Delhi in the north, Hyderabad, capital of Telangana, and Bangalore, capital of Karnataka. So, the requirement is that these 4 metro cities have to be connected, and you are already given the data for each origin destination pair or OD pair. So, you can notice that there will be flights connecting 3 other cities from every city, each of these 4 cities, and there are some routes like Bombay to Delhi route, where you can see that 6 flights per day are demanded. Then the next busy routes are Bombay Bangalore and Delhi Bangalore and Bangalore Delhi, where 5 flights per day are demanded. On other routes like Delhi Hyderabad, Bangalore Bombay and Hyderabad Bombay, you only need 4 flights, or you only look for 4 flights. Plus there are some routes which are very thin. For example, Bangalore Hyderabad and Hyderabad Bangalore, only 2 flights a day are demanded. Now please note that since we are looking at a toy problem with only 4 aircraft and we have constraints which I will elaborate very soon, it is not necessary that this entire demand will be met. So, you may not have 6 flights from Bombay to Delhi as desired or Delhi to Bombay as desired, but it clearly shows that some routes where more flights are demanded are high priority routes, and some routes like Hyderabad Bangalore in this case and Bangalore Hyderabad also, these are thin routes. So, you can schedule a flight here only if you find that because of some constraint flights to the other destinations are not possible. Now, along with the demand matrix, you are also given the flight time matrix, which shows in minutes the time taken to travel from each city to the destination city. So, for example, it shows that Bangalore to Delhi will be 180 minutes, and these routes are bidirectional. So, we assume that the time taken to travel from one city to the other is the same for coming back. So, if Delhi to Mumbai is 135 minutes, then Mumbai to Delhi also will be 135 minutes. That is the kind of assumption in this case. Now, as I mentioned before, there are several constraints which are imposed on operations of an aircraft. For example, there could be constraints due to maintenance. In this example, we see that all operations have to start and end from this particular city, Mumbai, because the airline is supposed to have its maintenance base at Bombay. So, therefore, all operations to start and end at Bombay. Then you have another important constraint, that all the aircraft, wherever they fly during the daytime on these 4 routes, they should definitely reach Mumbai by midnight, because the time from midnight to 6 AM is reserved for the daily maintenance. After 6 o'clock, they can be scheduled for flight, assuming that in these 6 hours the maintenance tasks are expected to be completed. There are also some more assumptions. One assumption is that we are looking at a single aircraft type. That means this airline only has one aircraft type which is flying on all these routes, and the turnaround time, that is the time between 2 flights at any point, the minimum time between the aircraft arriving and the aircraft departing is 30 minutes. Plus, there is another additional assumption, that to ensure that the market is not upset with the airline, we ensure that there is at least one flight per day on each route, even though the route may be low priority route, like the route from Hyderabad to Bangalore. There are only 2 flights required per day, but we will not sacrifice those 2 flights in the attempt to chase profit. So, we will ensure quality of service for the passengers by having minimum 1 return flight, or at least 1 flight on each route. Okay. So, now the task is to do the routing of these 4 aircraft on these 4 cities starting from 6 in the morning to midnight in such a way that the aircraft utilization is maximized. Now, we are going to look at the data for each OD pair in little bit more detail. So, on the left hand side you see the data regarding how many flights per day are expected to be flown or desired to be flown between each city and the other city. So, here we notice some asymmetry also in the data. For example, there are 3 flights which are supposed to be from Hyderabad to Bombay, as in the first column last entry, but there are 4 flights from Hyderabad to Bombay desired. This also can happen, although it is generally very symmetric, but need not be symmetricity. In the flight time, however, we can assume that it is symmetric, that whatever time is taken to go from A to B will be same as to go from B to A. So, we notice that one of the priority routes, which is Delhi-Bangalore, takes 180 minutes or 3 hours, and remember there will be half an hour for turnaround time also. So, each flight from Bangalore to Delhi will actually be 3 hours plus half an hour turnaround time. Mumbai to Delhi is also a busy route. There are 6 flights demanded per day, but the flight time is only 135 minutes, lesser than for Bangalore-Bombay. Plus, since it is a higher priority than Bangalore to Bombay or Bangalore to Delhi, therefore, we will try to push more flights between Bombay and Delhi, and then subsequently between Bangalore and Delhi and Bangalore and Bombay, and later on between Hyderabad to Bombay, Bombay to Hyderabad, and Bangalore to Hyderabad, Hyderabad to Bangalore. Let us have a look at the maintenance constraints once again. As I mentioned, all aircraft must reach the maintenance base, which is Bombay, by midnight. The daily maintenance time is assumed to be maximum 6 hours from midnight to morning 6 o'clock. So, therefore, flight operations can begin at 6 in the morning, and the turnaround time between 2 flights is assumed to be 30 minutes. With these constraints, now let us start doing the routing manually. So, to do this manually, let us first take advantage of something like a spreadsheet, where we can create time blocks of half an hour. Here I have shown the first window where I am looking at duration between 6 am to 9 am in slots of 30 minutes each. So, now remember, all the aircraft are at Bombay in the beginning, because they all arrived latest by midnight. So, at 6 o'clock in the morning they are all ready at Bangalore, at Bombay. At 6 in the morning all the aircraft are ready at Bombay. So, what we do is, for the first aircraft we assign a flight to the busiest or the most desirable route, which is Bombay to Delhi, for which we have to create 6 flights if possible per day. So, taking off at 6 o'clock, it reaches at 8 o'clock, and then there is a 30-minute turnaround time. So, at 8:30 the aircraft is now ready for the next flight. Similarly, one more aircraft, AC2, is scheduled from Bombay to Bangalore, and that leaves at 6 and reaches at 8, and there is a half an hour turnaround time. The third aircraft at Bombay is scheduled to Hyderabad. Hyderabad is comparatively nearer, so you can reach at around 7:30, and then you have half an hour. So, instead of waiting after that turnaround time, you can schedule the next flight. In this case, I have scheduled a flight from Hyderabad to Bangalore. Now, look at the next one, AC4. In AC4, we could have started the flight at 6 o'clock itself to Delhi, but there is a slight issue. Since there is already a flight from Bombay to Delhi at 6 in the morning by the same airline, it may be difficult to have 2 flights at the same time originating. So, what we have done is, we have given a half an hour idle time, so that the next flight can leave at 6:30. So, one flight leaves at 6 in the morning and reaches at 8, the other leaves at 6:30 and reaches at 8:30. After 8:30 there is a half an hour turnaround time. So, in this particular window, the first strip of about 3 hours, what we could achieve is as follows. We were able to achieve 2 flights on the Bombay Delhi route. There are two flights. This is the first flight and this is the second flight. Now, in this particular chart, we only count those flights which are completed in this particular window. Hence, you will notice that we have marked two flights Bombay Delhi completed. We have also marked one flight Bombay to Bangalore completed, which is this one, Bombay to Bangalore flight. We have also marked one flight from Bombay to Hyderabad completed, which is this flight, Bombay to Hyderabad flight. Okay. And the flight from Hyderabad to Bangalore, which is still in the air and not completed at 9:30, we don't count it in this particular window. So, we go ahead and now we look at the second window. The second window starts at 9 and goes up to actually 12. Okay. So, here what we do is the flight which had reached Delhi AC1, after turnaround of half an hour, we route it back to Bombay, because Delhi, Bombay, Bombay, Delhi are the main routes where we have to schedule the aircraft. They require 6 flights each per day. The one which reached Bangalore, number 2, that particular aircraft has been sent from Bangalore to Delhi. Why? Because you notice that Bangalore Delhi also was the second priority route, which 5 flights per day needed. The flight which went from Bombay to Hyderabad after turnaround time is going to Bangalore from Hyderabad, and subsequently from Bangalore it comes to Bombay. So, within the time of 12:30 with turnaround time, it completes its journey. And the one that had gone, the last one which began half an hour late and went and reached Delhi at 8:30, after 9 o'clock it is ready for departure. So, we use it to meet the requirement of the second busiest route, which is Delhi to Bangalore. So, therefore, in this particular window, what we have achieved is we have added one flight from Delhi to Bombay, which is this one. This is the Delhi Bombay flight we have added. We have also added one flight from Bangalore to Bombay, which is this one. The Bangalore to Bombay flight is here. We could also add one flight from Delhi to Bangalore, which was completed in this particular slot, this particular flight. Okay. So, these are the flights which are completed, and notice that there is one flight Bombay to Delhi which is still in the air at this time. So, therefore, we do not count it in this particular window, and the flight from Hyderabad to Bangalore, which was started in the previous window, has now been completed. So, it gets accounted in this window. So, in this window we have completed 4 more flights and tried to meet the requirement. Next block, if we just continue with the next block, in the next block we again, since the aircraft was at Delhi, we now send it to Bangalore. The one which was from Delhi to Bombay, we send it from Bombay to Hyderabad. The one which came to Bangalore from Bombay, turn around, it will be scheduled in the next one, and the one which came from Bangalore to Hyderabad is now sent to meet the requirement from Hyderabad to Bombay. So, in this particular window, the third window, cumulatively we were able to complete 3 flights from Bombay to Delhi, which are these ones. This is the first one, Bombay to Delhi. This is the second one, Bombay to Delhi. This is the third one, Bombay to Delhi. So, these 3 flights are now completed. On the Delhi-Bombay route, we now have 2 flights completed. You can see this is the first one, Delhi-Bombay flight, and this is the second Delhi-Bombay flight. So, on these we have met 2. On the Bombay-Bangalore flight, which is the second priority, you can see that you have met this requirement, Bombay-Bangalore 1 here, Bombay-Bangalore 2 here. So, these 2 flights have been completed, and Bangalore-Hyderabad we have also completed 1 flight, that is this one. This is the one that we completed in this particular slot. Going ahead, now we have to also keep in mind we have already reached something like 3:30 in the afternoon. Now, we have to start looking also at the considerations of bringing the aircraft, all aircraft back to Bombay. You cannot keep on scheduling from Bangalore to other places in the hope to run more flights, because then you may not be able to come back to Bombay at or before midnight. So, keeping that in mind, the next window shows you a flight that comes from Delhi to, from Bangalore, it comes to Bombay. Similarly, that is this one, that is this one. Then from Hyderabad we come to Delhi, from Bombay we come to Hyderabad, from Bombay we go to Bangalore, and at around 9:30, 7:30 all the flights have met this thing. So, what we have done in this particular cycle is we have got 2 flights now Bangalore to Bombay, we have 2 flights Bombay to Hyderabad. So, one of them is here, Bombay to Hyderabad, this one flight is here and the first one was here. So, we have kept now 2 flights between Bombay to Hyderabad, okay. And there is one flight from Hyderabad to Bombay and 2 flights from Delhi to Bangalore, which you can see here. So, total so far you have 2 flights from Delhi to Bangalore, one of them is here Delhi to Bangalore and then you have this flight Delhi to Bangalore. Moving ahead, this is almost the last window. So, the aircraft which was at Bombay has gone to Delhi, the one which was at Delhi has gone to Hyderabad, the one which was Hyderabad gone to Bangalore. And finally, what we see here is that now we have been able to meet 3 flight requirement from Bombay to Bangalore. Similarly, we are also providing 3 flights between Bombay to Hyderabad and 3 flights between Bangalore to Bombay, right. So, in this particular window, we were able to cumulatively increase the number of flights available and finally, since it is already 10:30, all the aircraft now have to head back to Bombay. So, all the aircraft, number 1 comes back to Bombay, reaches exactly at midnight, the second one reaches again at midnight, the third one reaches at 11:30 and idle for just half an hour and the fourth one reaches also exactly at midnight. Now, many of these things have been done only by inspection and observation. So, what we have found is that our aircraft remain idle only for, there are 4 aircraft and among these 4 aircraft, the only time we remain idle is just 1 hour in a day cumulative, half an hour in the morning, because we would not like to have 2 flights by the same airline from the same destination to the same destination from Mumbai. So, we have kept half an hour idle and in the end we have got an half an hour extra maintenance time for a flight. So, cumulatively you notice we have managed to give 4 flights in this day from Bombay to Delhi. Which are those flights? This is one Bombay to Delhi, this is the second Bombay to Delhi, this is the third Bombay to Delhi and then we have the fourth one will be this one. So, these 4 flights are Bombay to Delhi. Then we have 1 flight from Delhi to Hyderabad, we have 2 flights from Bangalore to Delhi in this particular slot, these things got added, okay. And finally, we have Hyderabad to Bangalore, we have managed to give 2 flights. Now, what do we learn from this exercise? What we learn from the exercise or from this toy problem is that finding the perfect schedule manually like the way we did is very difficult. A schedule that maximizes profit and also minimizes idle time, very difficult to get manually. And notice we had only 4 aircraft which were operating to only 4 cities. Imagine if the number of aircraft increases and the number of airports also increases, okay. Let us say we are doing the scheduling of the airline Indigo manually. Now, Indigo operates to 130 odd aircraft airports in this country. If I look only at domestic scheduling of Indigo Airlines, today as far as my knowledge goes, around 130 plus cities are connected by Indigo and the number of flights per day is more than 2200. Can you imagine trying to solve the problem of Indigo by hand? Not possible, and therefore, what airlines do is they use powerful software. One example of that is Sabre. Sabre is a tool that uses a combination of technology, that is data crunching, as well as the experience of schedule managers who have, so it is a decision support system which automates the information. So, you give some proposed schedules and you also specify the constraints and the data of the industry. It churns the numbers and then gives you some kind of a draft or a proposed schedule. The schedule manager has a look at that, or the team looks at it, and then they come up with an operationally feasible schedule. So, these kind of tools are very useful for the automated schedule generation for airlines. There are also some other softwares available. For example, there is a tool called AMPL, a mathematical programming language. This particular software has a demo problem on fleet assignment, which is available at this particular link. So, at your leisure you could go to this link and have a look at this very detailed fleet assignment problem. So, you can see this kind of output is generated by AMPL, tells you which aircraft flies from where to where and then remains and then again operates. So, at a glance you can get a 24-hour schedule for all the aircraft. In this case there are apparently 30 aircraft, there are 30 flights which are being scheduled, and each line represents one aircraft. So, you can see that there are 14 aircraft which are used for these 30 flights. I hope you enjoyed. Thank you so much.